Okay, we haven't got simply y equals, we've got the sine of x plus cos y is equal to 0.5. They've given us restrictions of x and they've given us restrictions of y, which will come into play a bit later on. And we're told that the tangent to C at the point P is parallel to the x-axis. So what that means is that whatever the curve gets up to, the tangent at the point P, I've got no idea what the shape of the curve is or whatever's going on, the tangent at the point P is parallel to the x-axis. So this gradient is equal to 0. And now we're asked to find the exact coordinates of all possible points of P, justifying your answer. So key words here are exact. So pi may be in the answer, or roots may be in the answer, but we must leave them there. And the fact that it's saying that all possible points of P, well, that will be restricted by the fact that both y and x have upper and lower limits. My diagram is just showing one point of P, but the curve clearly in some way repeats, such that you will get another point of P and another point of P, where you get another tangent to a second point P, also whose gradient is 0. So let's find out where this first point P is and then work out where P is repeated. Okay, so we start off in exactly the same way. We need to differentiate this equation and set the differential to 0. As I said earlier, we don't have y is equal to, so we have to use implicit differentiation. We need to find d by dx of each of these terms. The differential of sine x is easy because we're asking for a differential with respect to x. But cos y we can't do. But there's a trick. And this is the trick of implicit differentiation. Because if I say d by dx, in a similar way from the chain rule, I can say this is d by dy multiplied by dy by dx. Effectively, you see, the dy's cancel and you're left with d by dx, the differential with respect to x. So what it means is I can differentiate as though I'm differentiating with respect to y, but I must write dy dx next door to that y term. So I can say d by dx is equal to the differential of sine is cos x, no problem there. The differential of cos y, if we're differentiating with respect to y, is negative sine y. But, as I said earlier, we must write next door, this is multiplied by dy dx. And this is equal to the differential with respect to x of 0.5, which is 0. Maybe I shouldn't write the equal sign there. Maybe I should just say therefore. Because we formed a differential equation from our function equation. So that therefore sine y dy dx is equal to cos x. So dividing both sides by sine y, we get therefore dy dx is equal to cos x over sine y. Setting our differential function to 0, we get that cos x over sine y equals 0. Now, no value of sine y, because this only drifts between 0 and plus and minus 1, sine y can never give the result of 0. The only solution to this equation is when cos x is equal to 0. So I can say that therefore cos x must be equal to 0. And the cosine wave very, very roughly looks like that. The first 0 crossing point coming in a positive x direction is 90 degrees, so this is pi by 2 radians. And this point here going in a negative direction is negative pi by 2. If we look at our restrictions here, we can see we just get in on the negative side, so this guy is a solution, and this one certainly is a solution as well. So continuing higher in x values, the next time cos x is 0 will be another pi radians on, which will be 3 pi by 2, but we're told that the restriction is that x must be less than 3 pi by 2. So these two guys, minus pi by 2 and plus pi by 2, are our only two solutions. So let's try pi by 2 first. And we get sine pi by 2, our x value, plus cos y is equal to 0.5. Now the sine of pi by 2 is 1. So therefore 1 plus cos y is equal to 0.5. And therefore cos y is equal to 0.5 minus 1, which is negative 0.5. If you look up cos to the minus 1 of negative 0.5, you will get that y is equal to 2 pi by 3, which would be about there. And because of the symmetry of the cosine wave about 0, the solution on the negative side is negative 2 pi by 3. Are they acceptable? Yes, they are. The next ones, which will be 4 pi by 3 and negative 4 pi by 3, are not. They would be outside our y range. So we've got two perfectly good solutions. When x is equal to pi by 2, we've got that y can either be 2 pi by 3 or negative 2 pi by 3. Now let's try that x is equal to negative pi by 2. Again, popping it into here. So we get sine negative pi by 2 plus cos y is equal to 0.5 again. Now the sine of negative pi by 2, remember the sine curve comes down here, is negative 1. So therefore negative 1 plus cos y is equal to 0.5. And therefore cos y is equal to 1.5. And that must be wrong. There are no solutions because cos of y is restricted to plus or minus 1. So we get no solutions from the x value of negative pi by 2. So the conclusion is that we have two possible coordinates of p. Both have x values of pi by 2 and two different y values, 2 pi by 3 and negative 2 pi by 3. And that's the answer.